So without any further ado, please join me in welcoming to the stage from our innovator in this section, from OAL, it is Jake Norman. Put your hands together for Jake, everybody. Woo. Woo. There we are. Grab a seat, Jake. Good to see you. I'm going to say, again, I can almost call you a friend of the show now because you were on this, well, maybe not this very sofa, but on a sofa in a remarkably similar position this time last year, PPMA 2024.
This time last year, and thanks to that appearance, got me on the BBC, prime time.
Wow.
Nice 5-minute slot, got my 5 minutes of fame.
Well, let's see if we can up that to 15 minutes of fame this year, Jake. So for anyone who doesn't watch the BBC for whatever reason, or wasn't here last year, and perhaps isn't aware of what OAL does, fill us in, please.
So OAL, we're an automation and system integration business, so we're helping food manufacturers automate. My dad set the company up about just over 30 years ago.
Right.
It's a family business. He's a software engineer, developed in it. The thing we're most well known for is compliance. So we've got the most successful label and date code verification auto-coding system on the marketplace. It's on over 2,000 lines, protecting basically packaging errors. So stopping wrong packaging, wrong date coding, wrong product from entering the supply chain. It's compliance. It's really important for like allergen control, things like that, to make it right. And then extending those capabilities into robotics, so how you can apply robotics to improve a process, improve a function, to make it more efficient.
And of course, we're seeing, I mentioned a moment ago about in some ways, the leaps and bounds that we're seeing in technology capabilities on the software side. You know, we're also seeing that feed into the hardware side as well. So it strikes me as a really interesting, exciting time to be in your line of business when it comes to intelligent automation.
It is very exciting. It's very challenging. I think when you've got a boss, your CEO in a food company that can go on ChatGPT, can run awesome amounts of analysis, and then they go into a food factory and say, why have we got 1,000 people in here? There's a big challenge in industry in our line of work. Well, how do you get technology onto the shop floor so it's delivering sort of the savings in this big dream that everyone is expecting to come forward?
And of course, you know, we talk about technology. Technology isn't just the only enabler or the limiting factor. You know, people, process technology, but then there's also politics in there as well. There's all kinds of things that feed into the sometimes the reluctance or sometimes the speed or lack of at which some industries are able to adopt some of the innovation that we're talking about here on stage.
I think the biggest challenge that we see in our customer base is around skills. So having the right skills within organisations to adopt all these new technologies. Quite a lot of engineers are in that aging bracket where you're getting people retiring out of the industry. Where are we going to get all these people that are going to run all these lines, run all these systems? And that's where we've been helping a lot of food manufacturers sort of automate their lines and then also to continue to service them as well.
Well, let's talk about some of the ways in which you are helping your customers, and perhaps the best way of doing that is to see it in action first of all. So fingers crossed we have a live feed over to your stand elsewhere on the show floor here, and Mike is able to join us. There's Mike with a mic in his hand. Mike, can you hear us, and are you ready to chat us through what you need to talk us through?
Well, good afternoon, everybody. I can hear you. Can you hear me?
Yes, loud and clear, Mike.
Brilliant. So on demonstration today, what we'll show you is our 3D bin picking application in our fenceless industrial robot solution. I may as well go straight in there and explain why it's running, exactly how the system is integrated, how it's operational, and what we do in the event of external influences as well. So I'll launch the job now from the tablet.
So they can hear me as well. So this is hard. This is really hard technology because you're actually having to pick items that the robot hasn't seen before. And what we've done here is using deep learning and AI to allow you to pick out objects and then place them.
So we can see the vision system on screen there, or at least part of the input and output from that.
Correct. So in this application now as well, the hardware and how it's integrated allows us to be adaptive and agile to the working environment owing to its fenceless, collaborative nature. So we adopt such attributes as collision avoidance, and what the collision avoidance allows us to do is in real world we can put obstacles in front of the vision system and it would allow the robot to be augmented to go around those obstacles. One key note here with the solution is that being collaborative, we are able to interact with the robot in terms of, well, I'll let it run, stopping the robot. So we have what is a soft pad safe skin. It's internally monitoring the operators and the surrounding environment. We're able to restart. We have on the end of the actual end of arm tooling 2 layers of safety. So we've got a protective covering that encapsulates the tooling, but also beneath the tooling we have dual channel safety rated transducer. So what this allows us to do is maintain our finger safe certification, so that if the operator was to come into collision with the robot as just demonstrated, we're allowed to maintain the safe stop and protective stop and sensitive restarts as well.
And it's that recovery, isn't it, Mike, that's important if there is an intervention of some sort, accidental or otherwise. It's also important the machine's ability to be resilient to that and then to recover and then to get back to reliable operations as quickly as possible.
Correct, absolutely. And there are, when we look at an application, people typically will judge a cell or an installation by visually what they see. But it's also how we integrate and monitor the technology beneath in terms of its safety technology. So we have integrated a lot of behind-the-scenes safety-rated devices, which allow us to be very agnostic to the environment and dynamic to the situations that may be presented. So floor scanning, we can be sympathetic to whatever we're handling. We can slow down, we can restart.
Yeah.
But also what we allow the robot to do is to learn its environment. So we can launch other applications, and one demonstration here is what we call an adaptation. So what this is showcasing is how the robot can learn what's presented to it. So if we're handling sensitive fruits, for example, we can start to train the system to learn the object. So we've got a squeeze ball here. We don't go to a taut position, we go to a sensitive feedback. And what this can be is if we're handling sensitive objects like, for example, avocados, we can dynamically track the sizing of the presentation of these fruits and adaptively reteach the system to be very sympathetic to inhibit bruising, for example.
Very good. Very good. It's also, this sounds like a silly comment to make, but it's a good-looking machine as well, in as much as, you talk about the skins up there, you talk about the various pressure points, the touch points where you can put the machine to a halt as well. As we'll talk about with Jake in a moment, the fact this is operating in a fenceless environment means that you can get very close to it, but it doesn't feel as though it's particularly intimidating to work alongside, which is kind of the point of this.
Yes, I think it's one of those technologies now that people perceive industrial robots to be guarded applications, but with the correct risk assessments in place and the correct integration of safety technologies, this is certainly a new way to look at industrial robotics.
That's great. Mike, have you anything else for us, or are we good to come back to the studio here with your colleague Jake?
All done here, thank you.
Brilliant.
Thanks,
Put your hands
Mike.
together for
Great
Mike,
job.
everybody. It was a great demo. Right, we're back in the studio here. In the studio, it's a mini TV studio on a stage at the Live Demo Theatre. Jake, let's just expand what we were talking about there, because we saw that robot cobot on its own on a stand there, but what we're seeing on the screen behind us and in front of us right now is the more natural environment for that, and this helps to explain its application in the real world, and particularly why fenceless is important here.
Absolutely. So what you've seen there is right at the cutting edge. It's using deep learning, it's using 3D vision to do very difficult, complex pick and place activities. Where this is more in the bread and butter zone is around like case packing operations, palletizing operations, where you don't need intelligent 3D vision. We can use very much standardized 2D vision. Now, what that looks like in the real world is if I've got a person on a packing line, packing product into a crate or into a case, then if I was trying to automate that, I've got a couple of options at the moment. I could use a collaborative robot, but a collaborative robot will probably be too slow. And if I used an industrial robot, I need to put it in a cage, and quite often I wouldn't have enough space. So what we're able to do here is actually retrofit a fenceless robot into that space. We can keep up with production without taking up lots of space and having to disassemble the production line when we're doing it.
Okay, so you mentioned there's some of the applications for this system. What's it called? I might have missed it in the intro there, but what are we calling this?
We've just called it our fenceless case packer or crate packer or whatever it's going to be called. It falls within our April Robotics family of robotics technologies, but that always starts to get a bit confusing, I think, for end users. They just want robots on the line to do specific functions.
Okay, so it's not the fenceless robot 8000 AXE plus Ultra.
No. Although Mike would like that because he's into his Formula One.
Fair enough. And in terms of integration, because again, it's great to talk about technology and innovation, but unless it is easy enough to be able to integrate into your existing lines, then people aren't going to put it on their floor. So talk to me about what approach you've taken to integration with existing lines here.
There's a number of factors in play. Firstly, it's making it as a simple install and commission as possible. So a lot of the robot development time they've been put in place is to be able to do a near vertical startup. Now what that means to a manufacturer is install it in a day, commission it, and then it's off and running. In terms of the wider integration, this is where it dovetails very nicely into our compliance systems. We already have lots of vision systems out in the field that are making sure that every single product is right, and we validate it and verify it. By adding a robot on there, we can then start to also reject packs if it was wrong, but we also have the complete, I think M&S refer it to as an audit trail. So when Mike's referring there to data points on the pressure,
yes,
we can log and we can log that like we do on lots of other applications, and then give them the data to say, well, when we touched your steak, it's only ever had 100 Newton meters of force or something along those lines.
Okay.
To do it.
Excellent. I do want to put this out to you all if you have any questions about what we've just been looking at with this fenceless robot. While you're formulating those questions in your mind, a final one to you, Jake. Obviously, I've just been asking questions based upon what I've been seeing here and upon based on our chat a few moments ago before we came up on stage. But AOB, is there anything that you haven't that I haven't asked you that is also an important feature or important aspect of this fenceless robot that we haven't spoken about so far?
I think we've covered off the main basics really there, that if you've got a production line where you've got a person currently operating and then they're basically picking and placing items, and you maybe looked at collaborative robots in the past and gone, that's too slow, then you've now got a solution that can be retrofitted to the line to meet that pace basically.
Okay. Good summary, as it turns out. Fantastic. Any questions for Jake and OAL on the fenceless robot that we've just seen demoed very capably by Mike? Anyone have any questions or points they'd like to make? Then we have one question from the back there. Hello there.
Hi, hello. You mentioned how, in terms of identifying and picking up soft objects and making sure that they're not defective. Once you have identified them to be defective, is there anything in your robotic system that can actually take them out of the line and put them to another place?
So rejection, essentially.
Yeah.
Yeah, absolutely. That's a good question. So one of the challenges when you're installing vision systems like we do on the right-hand side here is, what are you going to do if you see a bad pack? Because if you stop the line, you're going to cause a lot of downtime in terms of production, and ideally you want to just reject it. So with the advantage of the robot, if we're case packing in this scenario, which we're showing here, then what we can do is if we get a bad pack, we can track it with an encoder and actually then reject it into a different spot, which would normally need to be a lock cabinet so that it can't be added back to the line. But the robot does the reject of the defective product.
And then at some point further down the line, you would be able to identify those products, those packs that were defective for some reason, do some root cause analysis, identify exactly what's happening to try and prevent that whatever failure that was identified from happening again.
Yeah, exactly. I mean, what you're tending to see is you would apply these types of systems much further up in the process, because you want to catch those defects as soon as possible. So on a cheese example, I want to get the cheese just as it's come out of the former, rather than it being packed and then picking up the issue then.
Of course. Any final questions for Jake from OAL? In which case, I'm going to call the live demo theatre. I'm going to bring the curtain down on the live demo theatre for today, but not until I've invited you all to put your hands together and show your appreciation for both Mike and Jake from OAL. Thank you.